statements x comma y we define the statement x if and only if y, which is defined to be true if either both x comma y are true or both x comma y are false and is defined to be false if either x is true and y is false, or y is true and x is false. So if and only if, for two statements x and y, we say that x if and only if y, or in other words, x is true if and only if y is true. If either both x and y are true or both of them are false, then this is true. If one of them is true and the other is false, then this is considered to be false. We use these notations to mean this thing. We can either write like this, or more popularly it is written like this: double implication. Okay. It's also, that means what it says is that this if and only if construct is true if x and y are equally true. Either both of them are true or both of them are false. In other words, they are logically equivalent. We say that two statements are logically equivalent if they have exactly similar truth values. Either both of them are true or both of them are false. So we can use this notation or this notation, and there are some other ways of writing this also. X is, of course, you can write like this by using more words. X is true if and only if y is true. Same thing. And apart from these notations, sometimes we also use this IFF. It means if and only if. It's a short way of writing if and only if. Okay. So this is the if and only if construct. It occurs quite frequently in mathematics, and it's a very strong statement. It says that two things are logically equivalent. Okay, let me give you some examples. X is equal to 2 if and only if x is equal to 2. Now this is a very trivial example. If this is true, then this is true. because it's the same thing. If this is true, then this is true. However, if I write x is equal to 2, if and only if x square is equal to 4, this will not be true. Why? And by the way, I have to mention that x is a real number. Note that, okay, recall